solving non-homogeneous. That's it, non-homogeneous a linear system. Okay, non-homogeneous linear system. Systems of the differential equation. That's it. Okay, now let's interest to see how we're going to get those system. Okay, so consider. Okay, consider the following system. Following system of differential equation of differential equations. So this is going to be the system that we have. So this is going to be dx dt as usual. And it's ax plus by. But there is going to be something extra here. And something extra is going to be a function of t. We call it f1 of t, just a real values function of t. And the second part, it's a dy dt. So that would be cx plus dy. The coefficient will be constant. You can do it for the, okay, otherwise too, but we stay with the concept. Okay, and this is going to be f2 of t. Okay, so this is going to be the system. So it is going to be, it is non-homogeneous. Okay, non-homogeneous linear system. Linear system. So we'd like to change it to the matrix form. Okay, it's going to be with the following matrix form. Following matrix form. So as usual, the first part we did it before. So it's going to be x prime is equal to the a times x. This part is just homogeneous. If you forget about this, that's going to be homogeneous. Then you are going to have a kind of a vector matrix or the column matrix. We call it f of t. Okay, this is going to be your column matrix. So this is going to be the case where A, as usual, is a matrix of the coefficients, A, B, C, D, and that extra part is going to be a matrix of function. So f of t is going to be a matrix. The first component is going to be f1. Okay, f1 of t, and this is going to be f2 of t. So it's a matrix of function. So you can integrate it, you can differentiate it. If you want to differentiate it, you differentiate each terms, okay, each interest. If you want to integrate, you integrate each interest, okay? You are going to be nice at differentiable function. Be able to do it. Okay, so the question is how we're going to solve it. As usual, it's a linear system. You know, we did it before, so it's going to be very similar. So in order to solve it, so the complementary, if you like, okay, the complementary homogeneous. Okay, homogeneous system, if you like, in matrix form is going to be x prime equal to the a times x. Okay, and we can solve this one easily. Find the solution. Okay, you know how you are going to solve this one. Just this part. Okay, so it's going to be the complementary homogeneous one, and can be solved, and can be solved. Okay, to get the solution. We get, let's say, xc equal to, you know, that there's going to be c1, x1, plus C2X2, as we did it before, as the general solution. Okay, as the general solution. We do it as we did it before, 3 cases, okay, with the distinct real values, complex, or the repeated one. Now we need a particular solution. Okay, so this is going to be the case. And now if X sub P, we call it, is going to be a matrix again, is a particular solution, is a particular solution of the homogeneous part, of course, the non-homogeneous part, okay, of this equation, which is X prime equal to the A times X plus F of T. Then the general solution of the equation is going to be X equal to the XC plus XP is the solution of the system. Okay, is the solution of the given system, that non-homogeneous. Okay, so that would be the plan, exactly as we did it for the equation. Now the question is going to be how going to find the XP. As usual, there are 2 different methods to do it. Okay, so there are 2 methods. And you know that the methods are going to be what? The methods are going to be undetermined and determinant coefficient. Okay, coefficients. And the other one is variation of parameters. Variation of parameters. Okay, there are 2 methods to find the particular solution XP. So that's going to be your job. If that function f of t is going to be a polynomial function, you can do it with the undetermined coefficient. Otherwise, you can do the variation of parameter. Variation of the parameter is easier for doing. I'll show you. But if it's going to be easy function, easy polynomial like the constant function, or a linear function, this that undetermined coefficient is easy to apply. But otherwise, the variation of parameter. But since we want to test it, we give you one from each, and we give you the instruction. Okay, so one would undetermine the parameter. It's going to be just polynomial. At most, is going to be linear. Even it's going to be quadratic, it's going to be quite a mess. It can be fine. But this is we are going to test it. Okay, so I do the undetermined coefficient first. For this one, you don't need any instruction. You have a true function this time, f of 1 and f of 2, and you want to create the XP. You just go on the components and you do whatever you did before. Okay, so let's do the first part by an example. Then for the second part, variation of parameter, you have to modify the result. Remember the variation of the parameters. The way we do it is we find the solution to the homogeneous one. Remember C1, Y1, C2, Y2. Then we change the C1 and the C2, the constant, into the function, U1 and the U2. Then we try and find it. So we do that one, just by means of the matrices. That would be easy in this case. Okay, this is the idea. Any question? Let's do it. Okay, that's it. I do 2 problems with this coefficient. Most of the time, you may get just a constant vector for for f of t, that the extra part, or a linear one. Okay, so let's do with the constant vector. So the first example is this one. We want to solve the system. Okay, solve the system. And this is going to be our first system. X prime is equal to, okay, X prime is, the matrix is -1, 2, -1, 1 times X. And the extra part is the column vector -8 and 3. So the function is a constant function. It's a constant, easily can be changed to the, okay, variation of the parameter for the XP. There is a constant function, so you replace it by 2 constant, and then you'll be able to do it. Okay, so you have to do the homogeneous one first. So solve the homogeneous solution. So we are going to solve this system first. Solve X prime equal to the -1, 2, -1, 1x first. Go for it. Then you have the matrix and you know what to do. This is going to be a matrix A. You have to find the eigenvalues. Okay, so the determinant, as we did it before, determinant of A minus lambda I, which is going to be the determinant of this matrix, is a -1 minus lambda, and this is 2. And this is going to be -1, 1 minus lambda. This must be equal to the 0. So cross multiply to get it. So it's going to be -1 minus lambda times 1 minus lambda. And this is going to be minus. We multiply to get that, give me -2, and the opposite sign make it to positive 2. Positive 2 equal to the 0. So we can FOIL it, or if you factor all the negative out, that's 1 minus lambda times 1 plus lambda. Okay, so it's going to be kind of 1 minus lambda squared plus 2 equal to 0. So that would give you a -1 plus lambda squared plus 2 equal to 0. So the result would be lambda squared plus 1 equal to 0. So you arrive at lambda squared equal to the -1. So the solutions are going to be complex. And this is I squared. So lambda equal to the positive -1. Okay, so eigenvalue are complex, we know that. If it's complex, we just pick one of them, the positive one, and we give you those formulas that we created. Okay, so I go with the lambda equal to the I. This is going to be our alpha plus beta I. So alpha would be 0, and the beta would be 1, with those formulas that we have. So you have to find the eigenvalues for this one. Okay, so you have to find the K. So K with the condition that A minus lambda I times K equal to the 0. That's how we find the vector K. So you are going to form this one. You know that you put the lambda equal to the I in this matrix. So that would give you, okay, it's going to be minus -1 minus I times 2. And that's going to be -1. It's going to be 1 minus I. This is going to be times it by K1, K2 equal to the 0. Okay, and you know that you need only the first row, but if you multiply them together, so that give you a -1 minus I, okay, times K1, and plus 2K2 equal to the 0. You don't need the second part because it's, that it's going to be, it's a dependent system with infinity many solution. So we stay with this one. If you stay with this one, okay, so just pick 2 numbers. You can find the K2. So this is going to be, you can, the second one is easier. So I may go with the second one. So that gives negative K1 plus 1 minus I times K2 equal to the 0. So that would be the system that we have. All of them are the same. So I go with the second one. So I pick this one. So the K1, it doesn't matter whichever. It's going to be 1 minus I times K2. Okay, you pick 2 numbers to get this. is true for all values. So I pick the K2 to be equal to 1. Okay, so K1 is equal to the 1 minus I. Okay, so the candidate for the K, so the K is going to be equal to the 1 minus I over 1. You know that you need the real part and the complex part of this one. So we have to break it. So we break it into the real part. The real part of the first one is 1. Second one is 1 plus I times the complex part. The complex part of this one is a negative 1. And the other one is 0. Okay, so this is the one that we call it B1 plus I B2, real part and the complex part. Okay, so the B1 is 1, 1, and the B2 is negative 1 and 0. Now you write the solutions. Remember, the alpha is equal to the 0 and the beta is equal to 1. Bring the formula that we talked about it the other night. So we get the x1, okay, x1 or x1 of t is going to be equal to, formula that we created is a b1 cosine of the beta t. Okay, the first one was minus b2, okay, b2 sine of the beta t times e to the alpha t. Okay, e to the alpha t, then you substitute. So in this case, your b1 is 1, 1. Okay, that's going to be 1, 1. Cosine of the beta is 1. Cosine of the t minus, the other one is negative 1, 0. Sine of the t. Okay, since alpha is 0, you see that's going to be, that's it. So that gives you x1. Okay, so if you want to put them together, this is going to be your x1. So the x1 is going to be cosine of the t plus sine of the t, first component, and the second component will be simply cosine of t. So this would be x1 of t. Okay, we repeat it to get the x2. Any question? So that's the case with the complex that we proved the other night. Okay, so for the x2, just change this b1 and the b2. So the x2, the formula for the x2 is b2. Okay, that's a b2. b2 cosine of the beta t plus b1 sine of the beta t times it by e to the alpha t. So if you substitute for this one, it's going to be equal to the b2 is a negative 1, 0. Okay, negative 1, 0, and this is cosine of the t, and the b1 is 1, 1, sine of t. Okay, so we put them together, that give you the x2. So the x2 is a negative cosine of t plus sine t and sine t. So this is going to be the x1 and x2. Okay, you know that. So far, you get the xc. Yes?
Does it matter what order we put the sine and cosine in?
You mean here?
Yeah.
The coefficient is important. Okay. Okay. So in this case, we already got the xc. So the xc is c1 x1 plus c2 x2. So that would be the homogeneous part. Any question? Now we have to get the, okay, to get the xp, the particular solution. So we check the function that we have. Okay, the function is a constant function. So we are going to use a undetermined coefficient to it. Okay, are you done? So going and doing the introduce the xp, then you have to substitute the xp as usual and its derivative into the general system and go and find those coefficients. So the next part is going to be how we're going to find the xp. Okay, so the xp is missing. We look at the f of t that you have. Okay, that extra term. The extra term is a constant vector, is a -8, and 3. Okay, this is going to be the case. So that will tell you that XP is going to be equal to, these are all just constants. So just change it into constant. Okay, so I'm going to call it A1, B1. So this is going to be the suggestion. Suggestion for the XP. Okay, so in order to get it, you go to the non-homogeneous case. Okay, you go to this equation, original one. So now you make it to the x prime of P equal to the A times XP plus F of T. You substitute into the non-homogeneous equation. Okay, x prime of P, you just differentiate the component. It's going to be 0, 0. Okay, because this is it, component A1 and the B1. So the derivative would be 0, 0. So bring it up here, substitute. So that give you 0, 0 is equal to 0, 0, the matrix A. The matrix A is a -1, -1, 2, -1, 1, times it by XP. The XP is A1, B1, okay, plus F of T, which is a -8 and 3. Okay, so we just substitute. Substitute, in this equation that we have. Now we have to find the A1 and the A2. We put them together, turn to the right, okay, then it's going to be the equality of two matrices, and two matrices are going to be the same if the corresponding components or entries are going to be the same. So this is it. We have to, this is going to be 0, 0. So multiply. You multiply these two, so that give you a -A1 plus 2B1 on the first entry. And the second one, multiply -1, 1A1, B1. So it's a kind of a dot product. So that give you -A1 plus B1. Okay, and then plus -8 and 3. Okay, I just multiply the first two matrices. Now you add them together. So this is going to be 0, 0. Okay, this is 0, 0, and then this is a -A1 plus 2B1 minus 8. And this is -A1 plus B1 plus 3. Okay, now let the entries to be equal to each other. So we're going to have this system of the equation. -A1 2B1 minus 5 equal to the 0. Okay, and the second one, -A1 plus B1 plus 3 equal to this. That's it. To solve this system, you can solve it by addition method quickly. If I change the sign, I can eliminate the A1. So I change the sign like multiplying by a -1. Okay, this is it.
Shouldn't be
Which one?
You have -5, which is
8, 8, yes, it's 8, thank you. It's 8. Very good, okay. So just using addition method to simplify it. So these two will cancel out. I have 2B1 minus B1 that okay, that give us a B1. And this would be minus 5. Oh, sorry, minus 11. Okay, it's a -8 minus 3, that give a minus 11. Okay, it's a minus 11, equal to the 0. So B1 would be 11. Okay, B1 is 11. You substitute one of them to get the A1. Okay. So you substitute the first one, that gives me -A1 plus 2B1. And B1 is 11, so 22 minus 8 equal to the 0. So that gives me -A1 plus 14 equal to the 0. So A1 is equal to the 14. So that's it. So XP is equal to, okay, A1, B1. A1 is 14, B1 is 11. So that gives you XP. Okay, so this one is straightforward. You have to get it. So you have to give us the general solution. So the general solution is this. We get x of t is equal to the xc of t plus xp. Okay, if you substitute, so that give you x of t is equal to, remember, c1, x1. So this is going to be c1. And that give you cosine of t. If they give you in the matrix form, you answer in matrix form. And if the system is, if they ask for the component one, and you just continue, but otherwise you don't. So that's a sine t minus cosine t. Okay, that was sine of t plus, plus the xp, which is 1411. Okay, that would be the general solution. Okay, in case they ask for the component, this is the way you just do it in case they ask for it. In this case, it's a matrix form accepted. If you want to find the component, you see x of t is going to be the first increase. It's going to be c1 cosine of the t plus sine of t. Okay, plus c2 sine of t minus cosine of t, and plus, plus 14. And your y of t, similarly, is going to be c1 cosine of t, plus c2 sine of t plus 11. In case, if there's going to be initial condition, something like that, it's in matrix form, and you answer in matrix form, we accept it right away. Okay, so this is just to get the constant vector. You see, I'm going to apply this one. Just give you one more to see, because there are some things that would happen when things is going to be more involved. So we give one more so that you can see it. And that would be the case that xp is going to be a matrix of the linear function. Okay, the linear function would be fine. Any question? So the procedure is like the one that you did before. Are you ready for I'm going to do one with the linear function. Okay, to see how we handle this system that will be resulted. Otherwise, it's not a big deal. Okay, so I'm not going to go more than linear because it takes time, and the variation of parameters are available, which we are going to see later. Okay, so let's do a little bit more of the linear. I have one linear. Put one in your practice one, okay, for the final. So it's very much a possibility to get the linear one on the final. Okay, are you ready? So let's try again, but this time, linear system. I mean, linear function for the f of t. So solve the system. How we're going to solve this system? Now your system is given to you in this format. We have the dx dt is equal to the 6x plus y, okay, plus 6t. That's the first part. And the second part, we have dy dt. Dy dt, which is a 4x plus 3y minus 10t plus 4. So that's going to be the second part. So as you can see, your function, you'll see the extra part is the combination of the linear function. The first integer is 6t, and the second one negative 10t plus 4. When you change it to the x of p, you have to change all those coefficients. So you're going to end up with 4 unknown coefficients. Yes?
You keep the t's in there, huh? When we're
We keep that?
to the x.
Yeah, as you did it before. You see, it's a polynomial. Remember, it's a polynomial. You change it to the same polynomial with the unknown coefficient. Okay? So let's change it to the matrix form. So this is it. So in matrix form, this is what we're going to have. We got the X prime, okay, X prime, matrix of the coefficient. We get the 6, 1, 4, 3. That's the matrix of the coefficient, and the matrix of the function. Okay, we get the 6t, and this is going to be negative 10t plus 4. So this is a situation with that. Oh, sorry, I missed an x here. So this is going to be your A, the matrix, and this is going to be your f of t. Okay, extra term that we're going to have. Again, we have to solve the homogeneous one first. Okay, so go for the homogeneous one. X prime equal to the 6, 1, 4, 3 of x. So we are looking for the xc. So for the matrix again, determinant of the A minus lambda I, which is going to be 6 minus lambda, 1, 4, 3 minus lambda, or 0. Carefully get the determinant. Okay, so we end up with the 6 minus lambda times 3 minus lambda minus 4 equal to the 0. Boil it. So that will be 18 minus 6 lambda minus 3 lambda plus the lambda squared minus 4 equal to the 0. Combine the like terms. So we end up with what? It's going to be lambda squared minus 7 lambda. Sorry, 9 lambda. 9 lambda and plus, okay, so it's going 1 plus 14 equal to the 0. So it's factorable. So we get the lambda minus what? Minus 7 times lambda minus 2 equal to the 0. So we have two eigenvalues. Okay, so the first eigenvalue, lambda 1, is equal to 2, for example. The second eigenvalue is going to be 7. So we have to find the K1 and K2. Let's put them together to get the XC. Okay, let's try lambda 2. So we go with the lambda 1 equal to 2. So we have to form this matrix A minus lambda I, okay, times K equal to the 0. So we go to this one as usual, and you put the lambda equal to 2. So in matrix form, so it's going to be 6 minus 2, 1, 4, 3 minus 2. Okay, this times it by lambda 1, lambda 2, and equal to the 0. Okay, simplify it. So that give you 4, 1, 4, 1. Okay, that's it. And the K1 and K2 equal to the 0. You know, both when you multiply together, both of them would be the same. So I go with the first one. Okay, this is it, plus lambda 2, K2 equal to the 0. So we get the K2 equal to the negative or minus 4K1. So I pick the K1 to be equal to 1 and the K2 equal to negative 4. So the first vector, okay, the first vector, I'm going to call it K1. It's going to be 1 and negative 4. That corresponds to the lambda 1. Okay, you have to repeat it for the lambda 2 equal to the 7. Same thing. Okay, lambda 2 equal to the 7. Again, form A minus lambda I times K equal to the 0. In this case, you go to the matrix and you are going to substitute lambda here. So the lambda is equal to the 7. So the matrix would be, would be 6 minus 7. 6 minus 7, 1. And that's going to be 4, 3 minus 7. So that gives me negative 1, 1. And this is going to be 4, 4. Negative 4, yes, that's a negative 4. Again, it's the same thing. So I go with the first one. So that gives me negative lambda 1 plus lambda 2 equal to the 0. So the K1 and K2 are the same for this case. So I pick one of them, K1 would be 1, and the K2 would be 1. So the corresponding, vector is going to be 1, 1. So that would be K1 and K2. Put them together, you have the homogeneous one. Any question? It's a straightforward operations. So we have the KXC, if you like. Okay, so we write down here XC. Okay, the XC is going to be C1 X1 plus C2 X2. Okay, you can come back and then correct that. So which is going to be, let me write it down, C1 K1. What's a K1? 1 negative 4 times e to the 2 lambda plus the second vector is 1, 1. So C2, 1, 1, e to the 7 lambda. So this is going to be the homogeneous solutions. Yes.
It isn't either the T.
What's that?
Isn't it either the lambda T?
It's a 2T. Yeah, thank you. It's a 2T and the 7T. Thank you. Okay. So this is going to be homogeneous one. Any question? Now the main one, find the XP. Okay, we go back. F of t is just a polynomial type, so we go and find the x of p. Are you done? So that first part can be one of those 3 possibilities that we did have before. Okay, so what is going to be the form for the xp? So there you are, xp is missing. You look at the extra function that we have, f of t. So f of t, the entries are polynomials, 6t, negative 10t plus 4. So the suggestion is going to be, you change it. So xp is going to be equal to, change this into the polynomial with that. Yes.
But 0 above the 4, it's just like 2 separate, it's not like 4, like 2 by 2, so 1 by 1, but you put the whole second function bottom.
What do you mean? It's 2 functions, f1 and f2.
Okay.
It's always a column function, okay? Because you have only, you have the scalar value, okay? So we changed the first one into a polynomial, okay? We can call it what is going to be. So a1t plus a2, okay? This is the notation that we use for the first one. For the second one, different notation, okay? So I'm going to use something like b1t plus b2 for the second one. Okay, you can call it whatever you like. That it's going to be 4 and no. Okay, because both of them are linear functions. So we have to change the linear function with the unknown coefficients. Okay, it's going to be your x of p. So you have to substitute the x of p in this equation to get your result. Okay, you have to put it into the x prime of p equal to the a times x of p plus f of t. You get your unknown. Okay, so we differentiate it. We differentiate it by differentiating the entries. Okay, if we differentiate the first one, derivative would be what? Would be a1. Differentiate the second one is going to be b1. That's going to be your x prime of p. Go back, substitute here, make an equation to be able to find those unknown. Okay, there you are. So that give you A1, B1 for the prime. Then the matrix. Okay, what's the matrix? Matrix was 6, 1. Okay, 6, 1, 4, 3. Then you have to multiply by XP. So what's going to be your XP is A1T plus A2. And that's a B1T plus B2. Then the function is 6T over negative 10T plus 4. This is the equation that we have. Okay, you are going to stay on the right. Simplify all this together. Then we get two metrics. Okay, two vector metrics. And then you change it to the system of the equation that enables you to find those four. Okay. So we are staying to the right to multiply these terms carefully. So it's going to be equal to, that's it, 6, 1. You multiply by this so that you what? It's a 6 A1T plus 6 A2. Okay, and followed by B1T plus B2. It's the first one. And then multiply 6, 1 is a dot product by those vectors. Okay, you do the second one, 4, 3. Multiply by this, 4 times the first one, plus 3 times the second one. So that gives you 4 A1T plus 4 A2 plus 3 B1T plus, 3 B2. So this is going to be the product of these matrices. And then it's going to be plus 60 minus 10T plus 4. So put them together. So what we have is A1, B1 is equal to, so you bring this 60 as well. Okay, so this is going to be the case. So this is going to be 6A, repeated, 6A1T, 6A2, B1T, B2, and the plus 60. And the second part is the 4A1T, 4A2, 3B1T, plus 3B2, minus 10T plus 4. That's it. Now let them to be equal to each other. And you have to organize it as a polynomial. Remember, two polynomials are the same if the coefficient of the corresponding monomials are the same. So then that equation, okay? So I'm going to put them equal to each other. So this is one of them, and this is going to be A1. I simplified a little bit at the same time. It's going to be A1 equal to. So I'm going to organize it as a polynomial. So I put those x's together, t's. Okay, so this is going to be 6A1 plus B1 plus 6 times t. So it's going to be the leftover. The leftover is going to be 6A2 plus B2. That's the first one. Okay, we do the same thing to the second one. B1 equal to the t's, 1, 2, 3. So the coefficient would be 4A1 plus 3B1 minus 10 times t. And the leftover is going to be 4A2. Okay, 4A2 plus 3B2 and a constant 4. Okay, so we let the entries to be equal to each other. Now we're going to use the fact that the polynomials are going to be equal to each other. You see the first one over here, the one to the left. There is no t, so the coefficient of the t considered to be 0. Okay, you can think about this one as 0 plus t. You don't need it, just to remind you. Okay, so yes, what's the question? Which one?
B1.
B1. Those coefficients are all, okay, letters, if you like. There's no numbers for the coefficients. Okay, so let the corresponding components to be equal to each other from the first part. This is what we get from the first part. The coefficient of the T is 6A1 plus B1 plus 6. Okay, this would be equal to the 0 because of the 0T. And the second one is going to be 6A2 plus B2 is equal to the A1. This is from the first part. Okay, now the second part. This is the second one. For the second one, you get 4A1 plus 3B1 minus 10 equal to the 0. And the constant term is going to be 4A2 plus 3B2 plus 4. This will be equal to the B1. Okay. So this would be equal to the, okay. That's going to be equal to the B1. So you see you have 4 unknown and you have 4 equations. To be able to deal with this, okay. You can pick this one in any order because all of them at the same time are supposed to be equal to the 0. Okay, to solve this system, usually you see this is going to be 1. So what you can do is, you see this is A1, B1, and this is A1, B1, nothing else. So you can take this one first. Okay, these two together, you solve it, you get the A1 and B1. So to go to the second one. You cannot take the second one right away because you have A2, B, A2, all of them are mixed together. So there's going to be one of them that you can solve it quickly. So this is it. I'm going to put these two together. You can put it in any order because all of them at the same time must be 0. Okay, we don't want to use, metrics or those type of ideas that you know it if you have already done the linear algebra. Okay, and you don't need it really. Okay, so I'm going to put these two together. So these two together, see the first, these two, because the unknown are just simply A1 and the B1. So this is going to be 6A1 plus B1. Okay, if you like, it's equal to the -6. And the other one is 4A1 plus 3B1 equal to 10. I solve this one first. That give me A1 and A2 and come back and take the other two. Okay, then you can solve it by addition method. I'm going to eliminate the B, so I multiply the first one by -3. Okay, so that give me, if I multiply by -3, so that give me -18. Okay, -18 A1 minus 3B1 equal to the +18. And over here, I have the 4A1 plus 3B1 equal to 10. Okay, so that would enable us to eliminate the B's. Okay. So what is going to be the result? So that gives you -14A1. -14A1 equal to 28. So A1, okay, A1 would be a -2. So that's going to be your A1. You bring it back here to get the B1. Okay, so A1 is equal to 2. So that gives us 6 times 2 plus B1 equal to the -6. So that will be 12 plus B1 equal to the -6. So we get the, which one?
A1 equals -2.
Oh, -2, thank you. -2, -2, so that gives us a -12. Okay, so what's going to be B1 now? B1 would be 6, yes? That's a negative 12. You move it to the other side, you get positive 12. Positive 12 minus 6 would be 6. Okay, so far, this is what we did. A1 equal to negative 2, B1 equal to 6. Okay, yes.
Why do you take one?
If you pick the other one, you have 3 variables, 2 equations. You can't do it.
Okay.
I picked the one that I have 2 unknown, 2 equations.
We always can have one.
You have to look. You have to look for it. One of them would be of this quantity. Yeah. Okay, because the other one is not possible. So look at them. You have 3 variables and 2 equations. You can't do it unless you do all of them together. You write down as a matrix 4 by 4 matrix. You know, use if you have done linear algebra, row echelon form, etc. But we don't need it really for linear algebra to do it. Okay, we are not done. You have to go back. You substitute these 2 numbers into those seconds. Okay, and then you continue. So bring the second one. You see these are 2. So this is going to be the leftover. You have 6A2 plus B2 equal to the A1. Now your A1 is negative 2. Okay. And the other equation that we left out is the second one. Okay, so the second one would be 4A2 plus 3B2 plus 4 equal to the B1. Now you have the B1, which is 6. You see, that's why I took the other ones. Okay, so you have to solve this system. I move the 4 to the other side and work on this one. So that gives 6A2 plus B2 equal to the negative 2. And you have 4A2 plus 3B2. I move the 4 to the other side and make this one as 2. Okay, there you are. You get something similar over here again. You get the A2 and the B2. You can use the addition method. You multiply the first one by negative 3, and you continue to solve this system. Okay, so what they're going to have is now it's going to be negative 18. Okay, 18A2 minus 3B2 equal to the 6. And the second part is going to be 4A2 plus 3B2 equal to 2. Add them together. These 2 will cancel out. Okay, this time that gives you negative 14 again. Negative 14A2, but on the other side we get 8. Okay, we get 8, so the A2 would be, negative 8 over 14. You simplify that, give you negative 47. So that gives you A2. A2 is negative 47. That's A2. I'm going to move it to this part to get the B2. Okay, I substitute here. So it's going to be 6A2, 6 times negative 47. Okay, plus B2 equal to the negative 2. So that gives us a 24. Okay, 24/7, negative 24/7. I move it to the other side. So it's going to be negative 2 plus. Okay, plus 24/7. 7 times 2 would be 14. 14 out of 24 would be 10. So that gives you 10/7. Okay, so that would be equal to the 10/7. So eventually this is going to be your B2. So we have all the coefficients to put them together that give you the XP. As you can see, you know, it takes time, but it's lots of fun, you know, it's all algebra to be able to do it. Okay, now we have to put them together, officially give us what is the XP. Okay. So I have to go to the next page and form the XP for you. Okay, are you done? So I have to organize it to give you the XP and then you're done. So this is going to be the final answer. So XP is equal to, remember the XP was A1 plus A2, yes? This is A1T, what's the A1? What is the A1? Negative 2T. A2, 6. That's A2, negative 47. Negative 47, okay, left it. And B1 is 6. So it's going to be 60 and the 10, 7, yes? 10, 7. That's XP. So the final answer, you know that. X is equal to the XC plus XP. That would be the final answer. If you want to list it, then you have it. Go back and get those numbers that we have. Okay. So this is going to be C1. Okay, you can just complete it by giving you those back. So this is going to be the final answer. C1, 1 negative 4 e to the 2t plus C2, 1 e to the 7t. Okay, and plus this one. If you like, you can write this. You don't have to, but you can write as a negative 2, 6t plus negative 4, 7, 10, 7. That's optional to give you a nice solution. Okay. That would be enough. Okay, to give this up. Okay, I give a break. Then method of variation of the parameter will be quite different things. Okay, there is a formula. You have two options. You can memorize those formulas that you don't know what's going to be the relationship between those, or just using the idea, very nice common sense idea really, with calculus and the linear algebra. Find exactly, remember the way we did it, that U1 and U2, and the formula that we create for the U1, we do the same thing, and the formula at the end will be very much similar. Very nice one. Okay, we'll discuss that one, and then we're done. We got 10 minutes. Method of, okay, variation of the parameter method. Variation of parameter. But this part is going to be, we are dealing with the system, okay, system of the equation. Before doing that, the only thing that we need from a linear algebra is to get an inverse of a matrix, okay? We don't need any complicated formula in your book to talk about it. The way we do it, since it's 2 by 2, so I just give you the formula. It's a shortcut, but probably you know it. So we just remind you as a remark, it's the only thing we need from algebra. So we just recall, okay, recall that if A is going to be a 2 by 2 matrix, this is the only matrix that we have, you know, that matrix of the coefficients. If this is going to be the case, then the inverse, okay, A inverse. The inverse of this matrix is 1 over the determinant of the A. The determinant of the A is going to be a number. I'm going to introduce this one for you. Times it by, okay, the way we are going to do it, we are going to switch the terms on the, okay, entries on the main diagonal, if you like. So this is A and D. We make it to the D and A. And then we are going to use the opposite sign for the other two. It's going to be negative C here, and this is going to be a negative B. Determinant of this matrix, we talked about it before. So this is going to be the one. The determinant would be AD minus BC times it by D, negative B, negative CA. This is going to be the inverse of the matrix. simply, when you do operation that we're going to have, there is a place that you want to solve an equation, and you divide. But we cannot divide by a matrix. The way we do it, instead of dividing, we multiply by A inverse, if you like. This is the only thing that we need to know. Okay? So if you multiply these two metrics, if you multiply the A times A inverse, or A inverse times A, that take you to the identity matrix, which is 1, 0, 0, 1, and this is identity matrix. This is the only thing that we need to know. Otherwise, we are safe to get these numbers. Okay. Now let's say I'm going to do the method of the variation of the problem. So there you are, to solve. Okay, to solve this system, to solve the system. This is going to be our system, x prime is equal to, or x prime of t, they are function of t. You can call it x prime of t is going to be the matrix A, okay, times x of t, and the function, okay, the function is f of t. To solve this system using variation of the parameter, using variation of parameters. Okay, so what we do is, as usual, we are going to do the, suppose we do homogeneous part, okay? Suppose x of t or xc of t is going to be equal to the c1 x1 plus c2 x2 is the solution or the general solution. Okay, general solution of what? Of the homogeneous one, of the associated or of the complementary. Okay, complementary homogeneous system. Homogeneous system. Okay, now this is the one that we are going to introduce at U1 and U2. In the case of the ordinary one, remember, we replace the C1 by U1 and the C2 by U2, and that would be the XP. The way we're going to do this one, I'm going to change it into the matrix form, okay? So note that this is the way I'm going to change it. That's a crucial part. And so this is it. I repeat it again. This is the x of c. This is cx1 plus cx2. So it's going to be c1, okay? And this is going to be x1, y1. Remember, the solution would have the component x1 and x2. And this is going to be c2, x2, and y2. Remember, when you substitute the x1 and x2, this is the way we write the final answer. Now I change it to the matrix form. Okay, the matrix form is this one. The first entries are going to be x1, x2. The second entry is going to be y1, y2. Okay, times that by c1, c2. Okay, if you multiply it, you get exactly what you have over there. Okay, so what I'm going to do is this part, the second part is going to be a matrix of t. I'm going to call this one phi of t. Okay, and this part, I call it a constant c because I don't want to repeat it in the matrix form. So what I have, the solution of the homogeneous one, the general solution can be written as phi of t times c. And this c is just, okay, you know that where c is equal to the just c1 and c2. Okay, I change it to the matrix form. Now I'm going to do the variation of the parameters. Remember the way we did it, we changed that constant. We changed the constant into the u and the v, u1 U function, if you like, U of t, U1, U2. Now I'm going to do the same thing, okay? And this is going to be the case. And now the particular solution, so we define xp to be equal to what? This is phi of t, the general solution that we have. We change the c into the function type. So we are going to call it u of t. But this u of t is going to be a matrix, and that is going to be u1 and u2, the one that you have when you use the method of the variation of the parameter. Any question? So this seems very much like the one that you did for the case of the linear system. Now remember the way we did it. We forced this one to be the solution. By forcing it means we substitute this one into the equation, and that would end up with the result, and that result gives us that equation. Okay, so let's do it. Okay, define this to be the particular solution. Particular solution of the system. Okay, so if it is going to be a particular solution, it must satisfy the system. Okay, so what is going to be the system that it must satisfy? It's going to be x prime of p is equal to that homogeneous system that we have. Is going to be equal to the a times times x of p, a times x of p, then plus plus f of t. So that's a system that we have, and this x of p must satisfy this system. Now let's bring it in. So what is going to be derivative of xp here? To find the derivative is the product of two functions. So apply the product rule. Derivative of the first times second, second first. They are all functions. So this is it. So what is going to be the derivative? So derivative of the first one, phi prime of t, times the second function, u of t, plus derivative of the second times first. What's the second? U prime of t. So it's going to be plus phi of t. Okay, it's going to be phi of t times what? Times u prime of t. Okay, it's going to be equal to what? Equal to the a times xp. This is xp. You multiply by a, so that give you a phi of t. Okay, a phi of t. And that is going to be the case, u of t plus f of t here. Okay, this is what we got so far. Any question? Now, again, you just go back. Remember phi of t? Phi of t is what? Phi of t is the solution of the homogeneous system. Okay, so that phi of t is the solution of what? The solution of this system, of the homogeneous one, of x equal to homogeneous one, x equal to the ax of t. That's homogeneous one. When it's a solution, so it must satisfy, sorry, that's x prime. So it must satisfy this equation. Satisfy means what? Means phi prime of t is going to be equal to the a, okay, a times phi of t. Okay, a times phi of t. Now go back and have a look at the above equation. Look at this one. To the left, you have phi prime of t, which is a phi. And you have a phi of t here. So both sides are going to be equal to each other. You can drop it. Okay, you can cancel out these two. So I'm going to take this one and consider it here. You see, phi prime of t. Phi prime of t is a phi of t. So this would be a phi of t, u of t. A phi of t, u of t. One of them are the same, and I can drop it. Okay, so I go to the next page to explain it. Okay, so what is going to be the resultant equation? I just substitute the phi prime of t. Okay, I substitute here, so that give me a phi t. Okay, so this is going to be the result. A phi of t, u of t. Okay, plus what? Plus phi of t, u prime of t. Phi of t, u prime of t is equal to exactly the same thing. A phi of t, u of t. And you have an extra term. What's that extra term? The extra term is going to be f of t. Okay, we just substituting into the equation. I did not satisfy. Now these two would cancel out. Because both of them are the same. So we end up with what? We end up with phi of t times u prime of t is equal to the f of t. But remember, the unknown is u prime. Exactly like if we did it variation parameter before. First, we find the u prime. Then we integrate it to get the u. So we want to find the u prime. If it was ordinary function, you divide by phi of t. But remember, phi of t is a matrix. So it's a matrix. Instead of dividing by the phi of t, we're going to multiply by the inverse. Okay? So the inverse of phi of t would be phi inverse of t. Okay, this is going to be phi of t, u prime. And on the other side, exactly the same thing. Phi inverse of t times f of t. But this part will disappear because this is going to be just identity matrix. So what's the result? Result is u prime is equal to phi inverse of t, f of t. You see, nice formula to find u prime. And we did a great job. We just copy, we don't copy, we modify it. The system that we did have before. Okay, this is u prime. But if you want to find the u, you have to integrate it. So what's going to be u of t? U of t is equal to what? Integral of phi inverse of t times f of t d of t. That would give you the u function. The u1 and the u2 that you start writing down for the variation of the parameters. But remember, you are looking for the xp. So what was the suggestion for the xp? The suggestion for xp was, we did have the phi of t, remember? We changed that constant into the ut. So what's going to be an xp? Xp is, substitute. You get phi of t, integral of phi inverse of t, f of t, d of t. That is going to be particular solution of non-homogeneous system of equation. Very nice one. You see, it's very easy to find. It's a 2 by 2 matrix. Of course, you can do it by n by n. You are going to be in linear algebra. You can, the same proof. The same proof can be, can take you to the other parts. Okay, so the only thing that you have to know is, you have to know this phi of t. And we just remind you that this is it, where, remember the way we build up the phi of t? Phi of t is just the homogeneous one. You see, look at the phi of t. Phi of t is, you see, we get the phi of t, the homogeneous equation. That's it. x1, x2, y1, y2. So just remind you that phi of t is going to be x1, x2, and this is going to be y1, y2. You start from here. As soon as you find the homogeneous equation, you find phi of t is a 2 by 2 matrix. You find the inverse of the phi of t. You multiply by f of t would be a function. You integrate it. Okay, you integrate it and you multiply by phi of t. There are a number of the algebra involved, but this is much, much better than, and some people, they memorize this. They don't go through the metrics. They give you 2 formulas to memorize it. But it doesn't make sense really. It's just a 2 by 2 matrix. And this method is much, easier than the other one. Okay, that's a method of the variation of the parameter. Very nice one. Any question? Let's try it. You see how we're going to do it. Okay. We like the proof. So we give you one, and then you have to find it for us. Are you ready? There are going to be messy operation of the integration, of course, involved. It's going to be e function, te to the t. You may have to use, a mild integration by part, but it's worth it really. If I give you the other methods, then, I used to talk of the other one because the people, they didn't have a good, good background, if you like, but it was terrible. When we want to solve one of them, nobody would touch those type of questions. Okay, there you are. Let me just give you one example to see how we're going to operate it. Okay, there you are. Example. Then you recognize it yourself. I don't have to tell you, use the method of variation of the parameter. You see, this is the kind of famous one, is they give you a couple of exponential functions. And it's easily happened in application, whatever discipline you are going to be. Okay, especially in physics. Quite a lot of these are going to be around. Okay, there you are. 2e to the negative t, 3t. You see, that's a system. Of course, they are not polynomials, so you better not try to, to do it with the variation of the parameters. Okay, so there you are. First thing to do, you have to do the homogeneous one. That homogeneous is important here because that gives you phi of t. Okay, so try solution. So solve this system first. Homogeneous. Solve x prime equal to the negative 2, 1, 1, negative 2, x. Get the matrix and keep going, eigenvalues, etc. So it's a determinant of, determinant of A minus lambda I, which is going to be negative 2 minus lambda 1. That's 1, negative 2 minus lambda, equal to the 0. Carefully find it, cross multiply to get the, determine negative 2 minus lambda is going to be times negative 2 minus lambda minus 1 equal to the 0. Okay, you can FOIL it or just factor out. It's going to be negative 2 minus lambda squared, really. Okay, so or you can FOIL it, doesn't matter. So it's going to be 4 plus 2 lambda plus 2 lambda plus lambda squared minus 1. Okay, so the equation is going to be lambda squared plus 4 lambda plus 3 equal to the 0. Nicely factorable. So factor it is going to be what? It's going to be lambda plus 3 times lambda plus 1 equal to the 0. So we have two solutions. So I write the lambda 1 to be equal to the negative 3 and the lambda 2 to be equal to the negative 1. Okay, go and find the corresponding eigenvectors. Start with the lambda 1 equal to the negative 3 and the form A minus lambda I times k equal to the 0. You put the lambda here. The lambda is a negative 3, so you are going to have a negative 2 plus 3, 1, 1, negative 2 plus 3 times it by k1, k2 equal to the 0. And so the matrix is going to be 1, 1, 1, 1. Okay, k1, k2. Just multiply the one row and then you're done. So the result would be k1 plus k2 equal to the 0. So the k1 is equal to the negative k2. So we pick the K2 to be equal to 1 and the K1 to be equal to the -1. That gives you the first vector. Okay, and this is going to be a -1, 1. Okay, so this is going to be one of them. Okay, I pick the K2 is equal to the 1, and that is -1. Yeah, that's correct. Okay, and so that's going to be that give us the first solution. Okay, and just continue to get the second one. So to put the K2 lambda 2 equal to -1, and the form A minus lambda A I times K. Go to the matrix and replace the lambda by -1. So the resulted matrix is going to be -2. Okay, a +1, 1, 1, -2 plus 1. So we get the same thing over here. It was a -1. Okay, so it's get the -1. Okay, it's going to be -1, 1, 1, -1 times the K1 and the K2. Okay, so you end up with the negative K1 this time plus K2 equal to the 0. So the K1 is equal to the K2. Okay, you pick the K2 equal to the 1 and the K1 equal to 1, and you get your second vector. So your second vector is going to be 1, 1. Okay, now we are ready to get the homogeneous equation solution. So this is it. The homogeneous solution is going to be x of c of t equal to C1. Okay, C1, K1. So the K1 is a -1, 1. Okay, times it by e to the -3t. And the plus the C2, 1, 1, e to the -t. So this is going to be the homogeneous solution. Okay, you need to put them together to get those x1 and the x2 that we talk about it because we want to get the phi of t. Okay, so for the phi of t, remember you have the x1 and the x2 that we talk about it. So this is going to be your phi of t. Phi of t, the matrix is x1, okay, x2, y1, y2. Bring those components. So for the x1, you see we get negative. So this is going to be negative e to the, okay, negative e to the -3t. Okay, that's 1. Or just, it doesn't matter really. Just go with the e to the -3t. This is going to be your x1 and x2, and this is going to be e to the -t. And for the x2, the second component, it's again e to the -3 here. And this is going to be e to the -t. So if you want to stay with those, just apply the negative sign, all of them together. Okay, so I repeat it again. So I picked the first one, which is the negative e to the -3t. Okay, -3t. The second one, e to the -t. And then for the second component, it's e to the -3 and e to the -t. So that's going to be a phi of t. Okay, it's a negative sign here. Negative sign. Okay, I can rewrite it. It's a phi of t equal to the first component is a negative e to the -3t. The second one, e to the -t. So this is going to be e to the -3t and the e to the -t. So this is going to be your phi of t. It's important to make this one correct to get the numbers. Yes, what's the question?
Where do you explain this?
You see, we find the x of t. So the metrics that we're going to have, okay, phi of t, are going to be what? Are going to be the component of these x of t. Remember, in the component form, you're just focusing on the first component that give you the x. Focusing on the second component that give you the y. So x1, x2, y1, y2, okay? So we got the phi of t. You know the formula for the x of p, okay? What is the formula? So the formula for the particular solution, remember, x of p is equal to what? Is equal to the phi of t times it by phi inverse of t, f of t, d of t. This is your formula. And for that phi of t that you have, okay? So I need to repeat phi of t again here because I have to find the inverse. I do the integration first. Okay, then I bring it up, multiply by phi of t again, so that gives you the final answer. So I'm going to make the inside. Okay, so the phi of t that we have, okay, negative, it's a negative e to the negative 3t, e to the negative t, and e to the negative 3t, and the e to the negative t. Okay, that is, yes, that is what we're going to do. Now find the inverse. We talk about how we're going to find the inverse. Okay, so we have to find the determinant first. So what's going to be the determinant of the determinant of phi of t? Cross multiply. It's going to be negative e to the negative 3t times e to the negative t minus e to the negative 3t times e to the negative t. Remember, when you multiply, we add the exponents. So this is going to be minus e to the negative 4t. And this is going to be minus e to the negative 4t. So the result will be negative 2 e to the negative 4t. Okay, it's like the round scan that you did before. So that's going to be the determinant of phi of t. Now we are ready to get the inverse of the phi of t. What is the inverse of the phi of t? I remind you the formula. It was 1 over the determinant of the phi of t, then you switch. Remember, it's going to be dA, and that's a negative c, and this is a negative b. So it's going to be equal to 1 over negative 2 e to the negative 4t times that by, switch the one in the middle in the diagonal here, so that give you e to the negative t. You switch the sign, negative e to the negative t, switch the sign, negative e to the 3t, and this would be e to the negative t. You get the inverse. You see, you switch the one on the main diagonal, and for the other one, you multiply by a negative 1.
What is the bottom right in negative 3t?
Negative?
E to the negative 3t?
No, you switch these two. You switch these two, and then opposite sign for these two here. So e to the negative 2 go up here. Negative, yes, you are right. This is...
E to the negative 3t.
Yes, you are right. Thank you. E to the negative 3t. Okay. And the rest is correct. That is going to be the case. Now, you have to multiply inside to get this one. So what is going to be phi inverse of t? You can keep the 1/2, or doesn't matter. You can multiply it eventually together. Okay. Or you can keep it. We have to multiply by phi of t as well. But you have to multiply because eventually you get the integral. Okay, multiply 1 by 1. Or you can move this one up, make it to the e to the 4t, and start multiplying. So e to the 4t times e to the negative t, that give you e to the 3t. But it's going to be negative 1/2. Over here, e to the 4t, that give you negative with the positive. So that give you 1/2 e to the 3t. If you multiply this one over here, that give you positive 1/2 e to the t. If you multiply this one, that give you positive 1/2 e to the, okay, e to the t. Okay, that's e to the negative 40 down the denominator. I'll move it up, make it e to the 40, and then multiply it by all the components that you're going to have. Okay, that's a phi inverse. Yes.
Yeah. Now you can 1 over negative 2 to the negative 40.
Yeah, you move the e to the negative 40 up. It's going to be e to the 40 divided by 2. Then you multiply. You see this one?
Yeah, the one that's good. Wait, time to do that. Maker.
You see this one? This would be negative 1/2 e to the 40. Then you multiply inside all those matrices. So if you multiply the first one,
This one, how did you get that? E to the negative t, negative e to the negative t. The matrix e?
this one,
Yeah, how did you get all of them?
the formula, we switch the entries on the main diagonal. You see for the inverse of the matrix. You see I switch the e to the negative t and negative e to the negative 3 and use the opposite sign for the text. You see that at the beginning, I introduce the inverse of a matrix that you're going to have. You see? That is the A inverse. You want to have the A inverse, what you do? You switch these two. That's AD, that give you DA. Then the opposite sign, negative B, negative C. So that's exactly, yes.
When I define my p function, I switch the column, so my determinant is negative. How does that affect the final answer? Like why? I assume you can do both.
What did you switch?
So the column of the
The case, whenever you.
Oh, you mean K1 and the K2?
yeah, so my determinant is negative.
It should be fine at the end.
Fine.
Yeah, fine at the end. Because you have to multiply this one by phi of t.
Oh, so okay.
Yeah. Okay, so we are not done. This is phi inverse so far. Now you have to multiply f of t, then integrate it. Okay, you can do all of them at the same time. Okay, so I'm going to do it step by step. So what's going to be phi inverse of t times f of t? Remember f of t is just original function that you have. So this is it. It's a negative 1/2 e to the, e to the 3t, 1/2 e to the 3t, 1/2 e to the t, 1/2 e to the t. You multiply by f of t. What is f of t? The original function. 2e to the negative t, over 3t. So that would be the next step. Remember, f of t is just the given function. Now multiply this one and then integrate it. Yes.
We're multiplying it. Does that mean we get the 2 separate values, 2 separate energies?
That's it. Yeah. So multiply. You see, this is it. A dot product. You multiply. So this is going to be equal to. Okay, you multiply this vector by this. Okay. So you multiply the first one. Negative 1/2 times 2, that gives negative 1. E to the 3t, e to the negative t, that gives e to the 2t. If you multiply these two together. Then you continue plus, you multiply these two together, that give you 3/2 t e to the 3t. That's the first one. You repeat the second one, the dot product. You multiply these two together, you will lose the 2, e to the negative t, e to the t, that give you 1. Okay? And then you continue, multiply these two together, that give you plus plus 3/2 of the t. So that gives you 5 inverse of the t times f of t. When you multiply, it's like a dot product. Okay. So this is one vector, this is the other one. You multiply these two together plus this one. Which one?
On the second one, 3/2 t, e to the t.
E to the t. Yes, you are right. E to the t. Okay, that's a 5 inverse of the t f of t. Now you have to integrate it. You integrate by integrating each row separately. Okay. So integral of 5 inverse of t, f of t, d of t. You go to the matrix and you integrate each entries separately. So what's going to be the answer? I write it down, then I do it. It's integral of negative e to the 2t dt. I do this one separately because I have to use the integration by parts for the for the other part. So this is again is going to be integral of 1 dt and plus 3/2, the same thing. Integral of a t e to the t dt. Okay, so you have a 2 mild integration by parts. You can use the table to do it if you like. Okay, so you remember this is it. They are easy integral even if you don't want to use the table. I'm going to find this one first. Okay, that's it. Remember, this is going to be positive. I put the t e to the 3t. Differentiate, integrate. So that will be negative 1. Integrate this one, that gives you 1/3 of the e to the 3t. You continue, that gives you 0. Integrate it again, 1/9 e to the 3t. So collect the information. So the integral of t. Integral of t e to the 3t dt is going to be equal to the 1/3 t e to the 3t, okay, minus 1/9. 1/9 e to the 3t. So that would be integral of the t e to the 3t. I do the other one too, then I go back and substitute to get the final answer. Okay, the other one that you have is t e to the t dt. You have to integrate this one. This is easy. You know, it's going to be e to the t minus t e to the t. This integral. Okay. It's going to be e to the it's going to be what? E to the t minus t e to the t, yeah? Which one? There is a e here. Okay, I do this one first. Which one? I have a t here. When you multiply the matrix, okay, that's it. You multiply these two together, there is a t here.
The bottom left corner.
Bottom left.
You have a bottom left corner. You have a T.
Where do you mean? This one?
The bottom left 1/3 T e to the 13 minus 1/9.
Integration by parts.
Professor, you have the second one backwards there. It should be t e to the t minus e to the t.
That's it.
Yeah.
Okay. Now go back, substitute. So these are the integration by parts part. The other parts are clear, if you like. Okay. Are you ready for the final answer? It's a 5 inverse of the t f of t dt. What's the metric now? We didn't integrate this. This is going to be 1/2. e to the 2t,
Negative.
negative 1/2. Then you have a 3/2 times the rest, okay? 3/2. 1/3 of the t e to the 3t minus 1/9 of e to the 3t. That's the first one. How about second one? You got 1 would be t. Okay, plus 3/2 times negative e to the t plus t e to the t. Okay? So you have to simplify then multiply by phi of t. That give you the that give you x of p. Yeah, you got the equation. Okay, that's it. Okay, let's see if we can do something about it. Can we simplify it? So what do we have? We have a negative 1/2 e to the 2t. If you multiply this one cross, so that give you 1/2 t e to the 3t. And if you multiply this one again, so that give you 1/6. Okay, 1/6 e to the 3t. No chance for simplification. It's as is. Okay, the second one, t minus 3/2 of e to the t plus 3/2 of the t e to the t. So that will be the result of the integral. Multiply by phi of t, then give you the final answer. Okay, so that was the integral part. Are you ready for the last multiplication?
Yeah.
Because remember, you have to find it multiply by phi of t. Because this is the u, if you like. This is the u1 and the u2. The first part is the u1, the second part is the u2 that you find. You have to multiply by phi of t to get the, okay, to get the final answer. Okay. So let's see, I tried myself, just make sure to get it right. Wait, I'm almost right. Okay, with this, we have a couple of, okay, I multiply by phi of t. Okay, so what is the phi of t? Okay, so there you are. The final part is this one. The way they do it, they just put all the matrices at the same time. Okay, and then they carry on. I guess do it separately. So this is it. That's the first part, or the last part. It's a phi of t, phi inverse of t, f of t dt. So this is going to be equal to, okay, we got that's a phi of t. So I have to go back and make sure you get it right. Okay, phi of t is e negative, okay, negative e to the negative 3t. Let me know if it's right, e to the negative t, and then e to the negative 3t, okay, times e to the negative t. Okay, that was the one. Then you multiply by phi of t that we did have. Okay, so what's going to be phi of t? Can you read that one? Negative 1/2 e to the, I don't have it, negative 1/2 e to the t, e to the 2t. Okay, repeat that phi of t that you have. Okay, plus 1/2 of, plus 1/2 of t e to the, okay, e to the 3t. And that's going to be minus 1/6, negative 1/6 e to the 3t. You have it yourself, you know, you can get it. That's the first part, and the second part is t minus 3/2 of the t minus 3/2 of e to the t. Okay, and 3/2 of the t e to the t. T e to the t. Okay, that's it. So for the last part, you have to multiply again. Okay. So what's going to be the final answer? This is it. You multiply dot product, you multiply the first one by everything on the top, plus multiply everything e to the negative t by the bottom one. So there you are. In negative would be positive. That give you 1/2 e to the 2t negative t here. Second one, minus 1/2 t e to the negative 3, e to the negative 3 and the positive 3 will cancel out. So the next one is going to be plus 1/6. That's the first part. Now you continue with the plus, you multiply e to the negative t here. So that gives you t e to the negative t. This will be minus 3/2. And this would be minus 3/2 up there. Okay, it's going to be 3/2 of t. That's the first row. Do the same thing to the second one. It's almost the same. So you multiply this one again. So this time that gives you negative 1/2. It's the same thing, negative 1/2 e to the negative t plus 1/2 of t. Okay, and this is minus 1/6. Okay, and that's it. 1/6, and you multiply the second one, which is almost the same. T e to the negative t minus 3/2 plus 3/2 of t. You have to combine the like terms. That give you the x of p. So x of p is this one. E to the negative t. We cannot simplify it, so that give you 1/2 e to the negative t. We have the 3/2 of the t and the negative 1/2 over here, 1.5, and that give you t. Okay, plus 1/6, and that's a t e to the negative t. That's the first one. Okay, and I missed the negative 3/2 and the 1/6. Okay, I write it down, then I simplify it again. So the second part is almost the same, negative 1/2 e to the negative t, 1/2 t and the 3/2 t, and that give you 2t. Okay, 2t minus 1/6 plus t e to the negative t and the minus 3. Okay, and then you combine those numbers. So your x of t is this one, 1/2 of e to the negative t plus t. These two numbers is going to be, it's going to be 9, okay, 9/6. It's going to be minus or the plus 8/6. Okay, that give you 8/6 and the t e to the negative t. And the second part, negative 1/2 e to the negative t, 2t. Okay, in this case, it's going to be minus 10/6. 10/6 plus t e to the negative t. So, believe it or not, this is going to be xp. Look at the numbers. Yes.
8/6 is negative.
Sorry?
The 8/6 is negative on the first term.
This one?
Yeah, it's supposed to be negative.
Negative, yes.
That's simplified.
Yeah, you simplify it. You get, what's that when you simplify it?
4/3.
4/3 and the 5/3. Final answer. I have to check with my notes to see if you get it right.
It's only there.
I got it.
You got it right?
Is that okay?
Yes. Yeah, I mean, but it's a nice, operation, really, that you're going to have. Okay, let's see what you have. I have here 1/2 of e to the negative t plus t e to the negative t minus 8/6, which is the number.
Oh, no.
And the second part, negative 1/2 e to the negative t plus 2t plus t e to the negative t minus 5/5.
Yeah.
I got it.
The second one.
Let's go. Okay. So that would be the operation. Again, as I told you, there are possibilities that you may have to use it in future, really. So that's why you have to know them. Okay. and it's not bad. I think that's it. Okay, so we do one more for you when we get to the review. The exponential part is the best case. Yes. Yeah, we give you one using undetermined coefficient, and the other one is variation of the one. You can drop one of the question. So you have to drop one of the. Okay, it's not. You see, when you get to the project, you got to be patient. You may have to be patient for several weeks to get one result. Okay, so something that you
Are you testing your abilities or testing your patience?
Okay, so no more new topics. Remember, we are going to get to the final move. Okay, it's not working in the final move.
So Wednesday and Monday, both gonna be reviewed.
Yeah, we get quite mad.
Is it cumulative? Is the final cumulative?
What do you mean? We did the final review. Yes, we give it the final review. Don't we have any?